All right, guys, today we're going to factor polynomials with three terms. Those are just called trinomials. And the method that we are going to use is factoring by grouping. You can factor polynomials with three terms or polynomials with four terms by grouping. And these are the steps that we are going to follow to factor. And remember, factoring is just taking an answer to a multiplication problem and breaking it back down into its original terms. All right, here we go. The first thing that I want you to do is look for a greatest common factor. And right here we have x squared plus 9x plus 20. There's not a variable or a numerical value that I can divide all of those by, so we don't have a GCF. The next thing I want you to remember is that this is in the format of ax squared plus bx plus c. So our a value in this problem is a 1. This is an understood 1x squared term. All right, so we're going to go ahead and rewrite this trinomial as x squared, but I want you to break your b term into two pieces, and we don't know exactly what those are going to be yet. So we're going to break that apart into two other terms, and then we have our plus 20 on the end. So how do we figure out what goes in these blanks right here? Well, I'll show you. We're going to multiply our a value of 1 times our c value of 20. We're always going to do a times c. So 1 times 20 in this problem gives us 20. And let's list out the factors of 20. We have 1 times 20, 2 times 10, 4 times 5. And of course, we could use negative pairs for all of these too to get positive 20. But I want the pair that combines to give me this positive 9x. Well, I'm going to use 4 and 5. So I'm going to break this plus 9x into a plus 4x and a plus 5x. All right, and now that we've done that, we've broken our trinomial into four terms. We can group together the first two terms and then the last two terms. Now, what can you factor out of x squared plus 4x? They both have an x variable in them that we can factor out or divide out, and we're left with x plus 4. In our second binomial, the 5x plus 20, we can factor out a positive 5. And I do think it's a good idea to always remember to factor out the sign with it. Okay, so we are left with just an x plus 4. Now, hopefully you recognize that inside our parentheses are exactly the same binomial. So this means both an x and this plus 5 are being multiplied by x plus 4. And we can write that even more simplified. We could just say x plus 5 in their own set of parentheses. That means they're both being multiplied by x plus 4. And that's it. All right, let's go to the next problem. 3x squared plus 3x minus 18. I look for a GCF and I see that all three of these terms are divisible by the number 3. So let's factor out the 3 and we're left with x squared plus x minus 6. So we did have a GCF here, the number 3, that we're just going to bring down the entire rest of the way. Every single step we just bring down our 3. So we've got 3, and I rewrite my trinomial as x squared, and I'll break that b term into two separate pieces, minus 6. All right, so remember we're going to multiply a times c, and in this case now my a value is the number 1, and my c value is this minus 6. 1 times negative 6 gives us negative 6. And let's list the factors. We have negative 1 times 6, 1 times negative 6, positive 2 times negative 3. We could do negative 2 times positive 3. So I want the pair that combines to give me a positive x. Remember, this is a 1 right here in front of this x. So the pair that I want to use that combines to make a positive 1 is a negative 2 and a positive 3. So let's write this as minus 2x and plus 3x. And now we can group our first two terms and our second two terms, or our last two terms, together. So because I already have this big set of parentheses, I don't like having too many. It's kind of hard to look at. So I'm just going to change this to a 3 and then a bracket. Now I have this first binomial, x squared minus 2x. Both of those are divisible by x. So let's take that out. And then we are left with x minus 2. In our second binomial, the 3x minus 6, we can divide out a 3 from both of those, a positive 3. So let's take out that plus 3, and then we are left with x minus 2. And that's why I like using brackets, just because I don't like parentheses back to back, but that's just a preference. If you like parentheses inside of parentheses, that's fine. It's just a grouping mechanism. All right, so here inside our big bracket, I see that x minus 2 is the binomial that we have left in each of those, and we factored out an x plus 3. So let's go ahead and rewrite that as x plus 3 times x minus 2. And of course, we have our 3 that we factored out in the very beginning, and that is our final answer. We don't need our brackets anymore because we've already grouped everything together. All right, last example, we have 18n to the 6th power minus 3n to the 5th minus 6n to the 4th. So I look at all of these values, and I actually have even more that I can factor out this time. Every single one of these terms is divisible by a 3n to the 4th power. I can divide all of these by 3n to the 4th power. So that's our greatest common factor. Let's go ahead and write down 3n to the 4th power. Let's scoot that up. Okay, so what are we left with? And I know I probably am just going to go ahead and start off with a bracket. When I divide out a 3n to the 4th power, we are left with 6n squared minus n minus 2, right? We're left with 6n squared minus n minus 2. If you were to multiply all that back out, we'd get 18n to the 6th minus 3n to the 5th minus 6n to the 4th. Yes, we can factor. All right, so now our new a value is a 6, and our new c value is a negative 2. So let's go ahead and break down further. We have 3n to the 4th power, bracket, and now I'm left with 6n squared, and I want to break that minus n into its two pieces, minus 2. So let's go ahead. Remember, it's our a value times our c value. So 6 times negative 2. 6 times negative 2 gives us a negative 12. So let's break down negative 12. We've got a negative 1 times a positive 12, or a positive 1 times a negative 12. We could do negative 2 times 6, or positive 2 times negative 6. And then, of course, we have our positive 4 times our negative 3, or our negative 4 times our positive 3. And again, we want our factors to combine and make a negative 1n. Remember, this is an understood 1. Negative 1n. So I'll go ahead and use this pair right here. And if you pay attention and you keep in mind what your b value needs to be, you don't always have to list out all of these factors. If you're good with your multiplication facts, it's a lot faster to factor this way. So we've got this negative 4 and our positive 3, so minus 4n plus 3n. And we'll go ahead and group together our terms. Here are our first two terms and our last two terms. So let's go ahead and bring down our GCF, 3n to the 4th power, bracket. What can we factor out of 6n squared minus 4n? Well, both of these are divisible by a 2n. So let's factor out a 2n. And when we divide out a 2 and an n, we're left with 3n minus 2. And when I look at our second set of parentheses, I see we have a 3n plus or minus 2 right here. So there's really no other GCF other than the number 1. So you've always got to factor out something. Always has to have something factored out of it. So all we can take out is a positive 1. And we are left with 3n minus 2. So when I look at both binomials, I've got a 3n minus 2 and a 3n minus 2. So 2n plus 1 can be written as its own set of parentheses. We've got this 2n plus 1 times 3n minus 2. We always have to have that 1 as a placeholder. And of course, we bring down our 3n to the 4th power, our GCF that we started with. That's how we can factor by grouping. Stay tuned for the next video, and I'll show you another method.